So up until this point, well, actually, you're the first exception to this, but I'll just say it anyway. Up until this point, most of what I've given you are one equation at a time, right? A system of equations is where you have more than one equation. Just like you would have a stereo system, right? A stereo system, what would that incorporate? What would that include? Basie, what would a stereo system include?
Like a stereo system is like, I think, doesn't in stereo kind of mean like all the same sometimes? Or stereo can mean like if there's a sound on the right side, you can hear it in your right side, and if there's sound on the left side.
Okay, but what if you had a sound system at your house? You'd have to have a CD player or something. You'd have to have, surround sound, so you'd have to have speaker wires, right? And you'd have to have speakers in the back of you and speakers in the front of you. You'd have to have some sort of an amplifier to amplify the sound.
So like,
right?
Instead of solving the TV, you're solving the whole entire system,
Well, a system means more than one thing, more than one part, right? A sound system in your home has wires and speakers and CD player, or what do you call these things? iPods or whatever, you know what I mean, all that stuff, right?
Apple?
Yeah, Apple. Or iPhones or whatever. So anyways, shh, guys. So, Jan. So what we're going to talk about today is when I give you two equations and we're going to be asked to solve those two equations. In other words, solve where those two equations, let's say I graph them, and I graph one equation that goes like this. And let's say I graph the other equation on the same graph, right? And it goes like this. Where do you think the solution would be? Where they're intersecting, right? That's what we're looking for. Because that point is a true point for both equations, right? That point is on both lines. You see what I'm saying? And that's what we're looking for. What point is on both lines, right? It's the same point. It's that point. So that's what we're trying to do. Very, very powerful method used in real life applications. You'll see lots of applications. Once we get the foundation stuff done with this, we're going to practice lots of word problems using systems of equations. They're really fun. They're really fun. Now, you guys already know how to do this to some extent because when I taught you number word problems, so Rico, I'm sorry, Addie, when I taught you number word problems, I taught you to do it with two equations. You remember that? And then you substituted something into the other equation. That is called solving systems of equations with substitution. So you already know how to do that. We'll be doing that probably tomorrow. But for today, we're going to focus on the first one, the very pictorial approach, which is graphing and checking your work, okay? So if I gave you, let's just do our first one. So our first system, I give you two equations. Y is equal to x minus 7, and y is equal to negative 1/4 x minus 2. All right, and I'm going to draw my graph here. So the first step, these are the steps, right? Number one is to graph each equation. Each equation on same graph. Right, on the same coordinate plane, right? This is my coordinate plane, this is my y, and this is my x. And I've got to have these, 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 1, 3, 4, 5, 6, 7, something like that. Okay, so I see, how would I graph the first one? Y is equal to x minus 7. How would I do that? Rosemary, what would you do?
You get the point of 7.
Yes. I go down on the y-axis, right?
Yeah.
And I go to, okay, 1, 2, 3, 4, 5, 6, 7, I put a dot. And then, what's my slope?
Your slope is 1 over 1.
1 over 1. So I'm gonna, from here, I'm gonna rise 1 and I'm gonna run 1, right? And I put a dot. And I can rise 1 and run 1 again if I want, put a dot. And then I'm gonna, actually, when you're doing systems of equations and you're graphing systems of equations, I suggest you do the slope many times, right? So I rose 1 and I ran 1. I rose 1 and I ran 1. I'm gonna rise 1 and run 1, right? Where are we? And then I'm gonna rise 1 and run 1, and so that we can just sort of see where we're at, right? And so forth. Okay, now, yeah, what's going on? Okay, there it is. All right, well, how would I graph the second one? Jaden, what would you do? The second equation.
You do the point,
Which is what? This?
-2.
What
Right.
is wrong with the marker?
I don't know. It's because I'm, okay. So -2. So I'm going to come down to -2 and I'm going to put a dot. Now, what's my slope?
Down 1.
Yeah, okay, so down 1 and over 4. 1, 2, 3, 4. Oh my God, that's sharing that same point that the other one shared. Just, you see what I mean? Right? So now I've got an equation, I've got a line here, right? And I have a line here, right? And so this point is my guess. We got to figure out what is that point. What is that point? It's 1, 2, 3, 4, down 1, 2, 3. So that says 4 comma -3. Do you guys agree with me? Yes?
-3.
This is my prediction that that is the answer.
So one of the equations, like, are these gonna be on the homework tonight?
Yeah. Yeah. So you're gonna have a bunch of two sets of equations.
Wait,
right?
wait, wait. How
Sets
did
of-
you get that number? I'm trying to.
So I went over, I gotta figure out where that is. That is over 4, 1, 2, 3, 4, down, that looks like 3.
It's a little bit hard
Right?
to graph. It's a little bit hard
Oh.
to
I mean-
draw the graph
just-
exactly like
Over
this.
4, down 3. So that's how I got that.
It was a little hard to see at first.
Yeah.
Gary, will
Now,
there be regular like set graphs?
I'm sorry guys, what are you doing? Hey, Dan, where are you going? Dan, I'm in the middle of a lecture, dude. All right, Logan, have a seat, please.
On the homework, will there be printed graphs already there
Yes.
so that
Yeah,
they'll
yeah.
be accurate?
Yeah.
Phew.
Yeah, it's a little harder because I'm not using graph paper right here, right? It's way easier when I use graph paper. But I want you to notice a couple things. Notice that because I used the slope on the first one many times, I went up 1 over 1, up 1 over 1, up 1 over 1, up 1 over, and I put dots in each one. Then when I did my second equation, when I reached a dot that was already there, I kind of had a good idea that I was at the right spot and I found the answer. Does that make sense? It really helps to do your slope several times in a row. Okay? So now, this is my prediction that that is the answer, 4 comma -3. But what if it was 4.0001 comma -3.00000002?
Well, it's not.
Well, I don't know. That point is, I don't know. It looks like it's there. I don't know for sure. So what I have to do is, this is the graph and the check method. You have to check it. So is the 4, which one is my x and which one is my y?
4 is x, -3 is y.
All right, so what I have to do is I have to plug this in to both equations and see if I get a true answer, right? Like I get 4 equals 4, or 6 equals 6, or 10 equals 10. If I get something like 2 equals 5, that doesn't work, right? That would not be a solution. I want to know, is this point a solution to this equation? So let's take the first one. Y is equal to x minus 7. All right? So my y is -3. So in place of y, do you see what I'm doing? I'm taking this point, this -3, and I'm substituting y with -3. And then equals, instead of x, I'm going to put 4 minus 7. Now, what is 4 minus 7?
-3.
-3 equals -3. Is that true?
Yes.
Yes, it checks. Okay? Now, am I done?
No, because you have to do the second
I
equation.
have to know for sure that it works for this one as well. Does that make sense? So here we go. So y is equal to negative 1/4 x minus 2. So again, my y is negative 3 is equal to negative 1/4 times 4 minus 2. All right, so negative 3 is equal to, well, I know negative times positive is negative. So I know it's going to be negative. And then 1/4 times 4,
It's gonna be -1.
right? Those cross out, so it's 1, and then minus 2. Negative 2 and negative 3, negative 1 and negative 2 is negative 3. So negative 3 is equal to negative 3. It checks. All right? Does that make sense?
Yeah.
It's really pretty straightforward, Jan.
And if it doesn't check, what do you do then?
If it doesn't check, then you say, let's say it said negative 3 is equal to negative 7. So Mushi, this is a good question. If it said negative 3 equals negative 7, I would say no solution, right? No solution. Meaning there is no solution, right? Well, actually, no, wait, let me think about this. No, wait a minute. I would not say no solution, sorry.
You just got the wrong solution.
I got the wrong solution. So I would say this, I would say not easy
Not easy.
Not easy.
to solve
Not easy to solve.
graphing.
What if we put N-E-T-S?
Wait, listen.
Not easy to solve.
The trouble, wait, guys, listen, this is important. The problem with solving systems by graphing is if you have a graph and your point is right here, right? Where they cross, oh my gosh, I have no idea what that is.
Crazy ball.
You know what I'm saying? It could be, like if this was my graph, right? That's like over 2 and something up 1 and something, but I don't know the something. You know what I'm saying? And I could guess and check for 10 years and be wrong. Does that make sense?
Yeah.
So as long as it crosses right on a grid, like right here, right in a corner, that's good. But if it crosses in the middle somewhere, that's not easy. And so if it doesn't work, your hypothesis is that's the point. Then you check it and be sure. If it doesn't come out, you're just going to say it's not worth trying to guess again. You know what I'm saying? It's better to just say not easy to solve by graphing, right? Okay. Wait, Irene had her hand up first.
If you had -3 equals -3, and for the other one you had like 5 equals 5, would that be correct? Or
That is
incorrect?
correct.
Okay,
Because
so
they
don't
both
all-
have to give you a true statement at the end. And if they do, then that means that point is a solution, meaning it's on that line.
Yeah, so it doesn't have to be the same thing.
It doesn't have to be, oh, I see, oh, that's interesting, isn't it?
Yeah.
Oh, wait, well, actually, I see what you're saying. Yeah, that would be, you're right. Because in this particular, it doesn't have, it could be -3 equals -3 and 5 equals 5.
Okay.
But,
okay.
but when they're both in y equals, then they're gonna both be the same. Because y is always the same, right?
Oh, yeah.
See what I'm saying? But when they're in standard form, it may look different. We're gonna do a standard form next. Yes, James?
2 things. One
Yes.
is, can we just shorten it to N-E-T-S-B-G?
No, because I would never know
Can
what
we
the
just
heck you're
shorten it
talking
to
about.
no?
Can we just write down net?
No. Is that clear?
Can we put
Jack,
nets,
not
not
easy
easy to solve?
Here's
Nets.
Net.
Okay. Question, yes, somebody.
Can we just put like
Wait,
can't?
Done.
Is it possible
Can't
to
graph.
have the
Wait,
first
guys.
one be true and the second one not be true?
Yes, that is possible.
And then is it wrong?
That means it's not, see, in order for it to be a solution to a system, it has to be true for both of the equations. Or all of the equations. It could be 3 equations, or 4 equations, or 5 equations. There are systems, but in Algebra 1, we will only be dealing with 2 equations. In Algebra 2, you'll be moving on to 3 equations. I don't think you ever do more than 3, usually. In Algebra 2, but you can. Question?
For the not easy to solve by graphing, can we just put a no?
Nope.
Net.
Nets.
Can you
I'm
just
not
put
gonna write that
nets
out.
by graphing?
I'm not gonna write that out.
Put nets.
That's
Not easy to solve, nets.
Why don't we just put
You're
nets by
welcome to
graphing?
write better to solve algebraically.
How about no?
Gary, what about
No.
nets?
What about nets by
Nets.
graphing?
Oh, okay, whatever. Okay,
Nets,
yeah.
we're putting nets.
We don't want to write that. This
I
is
noticed.
math class.
Gary, I'll
not
put at the
English.
top of my paper, nets.
Guys, we have to keep quiet because there's a presentation there. All right, so now we're gonna do another one. Okay, you ready? So obviously, in order to do these, you have to be pretty good at your graphing, right? You don't want to be rusty on your graphing,
Yeah.
right?
I don't think it's-
All right, here's our second one. So
you
x
notice you only have
plus
one step.
2y is equal to 7, and 3x minus 2y is equal to 5. So you guys should write that down in your notes.
Gary, you should change steps to just step, because it's just one.
Oh, what did I do? Wait. Graph each equation on the same graph. Okay, 2,
Step.
you know, like,
Two.
guess the point, right? And 3 is check the point, right? Check the point. You understand that?
Yeah.
Yeah.
Those are the 3. Thank you, James, for telling me that I only had one step to my 3-step.
I'm just gonna take away the S,
Okay.
just step.
All right, so here we go. Now, what's the difference between this one, this system and the previous one?
Oh.
It's in standard form.
It's in standard form. They're both in standard form. Is it okay to have one equation
It
in
doesn't matter.
slope
when the
intercept and one in
graph is
standard?
the same.
Yeah, it doesn't matter, right? We just have to know how to graph them, right? So for the first one, I'm going to do the first one first. X plus 2y is equal to 7. And I'm going to use my x and y t-chart, right? Okay, so if x is 0, I've got 2y equals 7. So that would be 7 halves, right? Which is around 2 and, well, it's 2 1/3. Am I right?
Wait,
Yeah.
7 halves or 7/3?
Oh, wait, 7 halves. Sorry, 7 halves. I said the wrong thing. 7, so that's 3 and 1/2, right?
3.5.
So that's pretty easy, really, right? When you're talking about half, that's
Yeah.
pretty easy to graph. It's hard when it's like, 3/7. That would be hard. But 1/2 is pretty easy. Okay, now let's try, when y is 0, x is
7.
7, right? So let's plot them. Okay, so I've got 0, 3.5. 1, 2, 3.5, right there. And then this one is 7. 1, 2, 3, 4, 5, 6, 7 dots. Now, I'm going to draw my line. Now,
There's nothing special.
you may notice something. One thing that's hard, so Mushy, it's important. One thing that's hard about solving by graphing is you have to be outrageously precise. Otherwise, it's going to be hard to find the point. Does that make sense? Do you see why? Because, like, if I had 2 dots,
Can
right?
you give us rulers?
If I had 2 dots, yes, you're welcome to use rulers. But if I had 2 dots that were close together and I connected the line, I could connect it like this, I could connect it like this, I could connect it like this. And don't you think over a period of distance, that's going to make a huge difference? Huge, right? So they've got to be precise. So one thing I might think of is, oh, well, my slope is from, 3.5, negative 3.5 to 7. You know what I'm saying? So anyways, that it's just hard. It's going to be harder. It's going to be a little trickier because it's not in slope intercept form. I don't have my slope going down every, I don't have any way to do that. So it's going to be more of a guess. Okay, let's try the next one. 3x minus 2y is equal to 5. So let me just erase this. All right, and then we've got x and y. X is 0, y is 0. Okay, when x is 0, we've got y is equal to negative 5/2. Am I right? Which is negative 2.5?
Yeah.
Yeah.
2.5. Okay? And when y is 0, I get x is equal to, divide both sides by 3, 5/3.
Uh-oh.
So those are both kind of tricky, right? I'm going to be kind of lucky if I guess this. Does that make sense? But I might. I mean, it's worth a try. So, okay, so 5/3. So what is that? 5/3, it's 1 2/3, right?
1.66.
All right. Okay, so here we go. Let's try it. So 0, negative 2.5. Negative 2.5, around there. Okay? And then 1 2/3, 1 2/3, around there. Something like that. 0. Okay, so let's just try. I don't have any straight edge, do I? Okay, hang on. All right, so to me, this point looks like 1 2 3, 3 comma 1 2. I'm going to guess that. You see how it's a guess? In this case, it's more of a guess. When they're both in slope-intercept, it's so much easier, right? Did you see that? But in this, when they're both in standard, it's more of a guess, right? Because it's floating out there, and I'm not quite sure. So let's try it. So that's why I have to check my work. So let's check. First one was x plus 2y equals 7. And again, this is my x, and this is my y. So x is 3. 3 plus 2 times 2. Am I right? Y is 2. So 2 times 2 is equal to 7. So 3 plus 4 equals 7. 7 equals 7. It checks.
Yay!
Yes. Okay.
Cha-ching.
Let's try the next one. 3x minus 2y equals 5. And my x is 3, so that's 3 times 3. You guys all see what I'm doing? Okay, does that make sense? I'm just plugging this into the x and this into the y. Minus 2 times 2 equals 5. So that's 9 minus 4 equals 5. 5 equals 5. Oh my gosh, I'm lucky. It worked, right? Fist of 5. Does it make sense?
Yep.
Okay. 4.5. Shall we do one more?
So we're all getting point slope,
Let's
right?
do one more. Let's do
No,
one
no,
more.
no, no, no. It's
Yeah.
okay, Gary.
Okay.
No, we're
Do one more.
good. We
One
get
more.
homework now.
No, Gary.
No, it's really okay. We all get it.
No, it's okay, Gary. It's okay.
Gary, it's okay.
Gary,
Frank?
Gary.
I can tell you guys really want to do one more.
No, Gary. You must respect our wishes.
You mind?
You haven't made a single wish.
I wish to do my homework
Too
now.
late now.
Oh my God, she's But you can't talk.
Gary, Liz, it's really okay. You don't need to do this to yourself.
Do it, Gary. Make him feel pain.
I see Liz.
All right. How about
Is this your?
Liz. Like the way you abbreviate these.
all right, 3. Here we go. X equals y plus 5. Okay, guys, write this down in your notes.
X equals my plus b. X equals my plus b. Well, no, it's just x equals y plus b. So what?
It's gonna stop confusing me. Celia almost made me write something else.
X equals my plus b.
Okay. Okay, x equals
I
y
knew you were
plus
going to do a
5.
combination.
What's the problem with that one? Yes, Sienna.
Well, wait, the problem with
What's
that
the problem
equation?
with this equation?
Oh, I don't know.
What form is this in?
Well, x equals my plus b.
What's the problem? It's got to be in, if you're going to use a shortcut, if you're going to use one of the shortcuts, it's got to be in one of those shortcut
You just
forms.
subtract y from y plus 5, and then you subtract x. Yeah, then you subtract x, so you get x minus y equals x minus 5, and then it's in
You get negative y equals negative
All right, so yeah, I like Basie's idea. So he's saying whoops, sorry, plus 5. He's saying that we want to say y equals, right?
Yeah.
And so y is there, we just got to get rid of this. Subtract 5 from both sides, right? So then suddenly x minus 5 is equal to y, right? Which means y is equal to x minus 5. Am I right?
Yes.
They're the same thing, right? So there's our first equation. Y is equal to x minus 5. So
Wouldn't it be negative y? It would.
say it again.
Wouldn't it be negative y, negative x? The second one is improper too.
What?
What are you saying?
Oh, never mind.
If you had subtracted y from both sides, right? Then you would have had negative. Then you would have had to multiply everything by negative 1. But we didn't do that. We just subtracted the 5. So we still had a positive y. If that is equal to y, then y is equal to that, right? We just rewrote it. Okay? So negative 5. 1, 2, 3, 4, 5. Put a dot. And it's up 1, right? Slope is 1 over 1. So up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over... Up 1 over 1. Sure
It's
would
like a
help me out.
lopsided line.
Up 1 over 1.
The line is lopsided, Gary.
Nice, Miss Gary.
Gary,
This is what you do, is you make it work.
you're cheating.
Okay, so there's my first line. Oh, look at that straight line.
Oh, cheating.
That's a lovely straight line.
Beautiful.
Okay.
That arrow.
Alright, so with this one. Now with this one,
You make a
I-
picture.
I could make a T-chart, or if I wanted to, it would be really easy to turn this into slope-intercept form. What would I do to turn it into slope-intercept form?
You would subtract 3x from both sides.
Subtract 3x from both sides, so 3x becomes negative, right? Does that make sense? So suddenly y is equal to negative 3x plus 3. That's going to be a lot easier to graph with this, right? So I've got up 3, I put a dot, right? And then I'm going to go down 3 and then run 1, right? So I'm going to go down 3, 1, 2, 3, run 1. Put a dot. Down 3, 1, 2, 3, and run 1. Put a dot! There it is. See, that's what I got to do. So I said, and then everybody's going to be so... All right, so what do you predict that point is?
It is
What is that point?
2, negative 3.
To me, it looks like 2, negative 3,
Haha.
right? But now I got to check it. So I got to go back to my original equation. X
Goes to school.
is equal to y plus 5. And this is my x and this is my y. So 2 is equal to negative 3 plus 5. Is that true? 5 minus 3 is 2. 2 equals 2. That checked.
Wait, what? 2 equals 2? I did not know that.
Yes.
Wow, I'm so surprised.
Now I got to do the other one.
Wow.
Can somebody explain to me why, guys? Can somebody explain to me why I'm going back to the 2 original equations and not the things that I have changed them to?
Because you don't mess with the universe.
Why? Can somebody explain?
There is a why you don't.
Why would I go to my original equations and not these other ones that I did stuff to? Why would, these are my 2 original equations. These are what I'm checking with. Does that make sense? I'm not checking with what I altered them to be. Why? So I mean,
Because they have to be like exactly the same for it to work.
yeah, Rico, I'm sorry, dude. Shh, listen, this is a good question, right? Listen to the answer, right?
And like they have to be the same for it to work.
It would work, assuming I did everything right here, it would work. But that's a big assumption, right? If you're sending a man to the moon and you made all these things and then you didn't go back to the original 2 equations, you might have made a mistake here, right? And then it worked because you're using the wrong equations, right? So it's better to go back to your original equations, right? So my original equation, 3x plus y, is equal to 3. And then my x is 2. Guys, I'm sorry, it's 2 noisy plus, or minus 3, really. is equal to 3. So 3 times 2 is 6, minus 3 is equal to 3, 3 equals 3. That checks, it works. Just a 5? I know, I just want to see if they went up at all.
Like,
So, does it make sense to you a little bit?
it's kind of like broken fourth finger.
Alright, so that's what we're gonna do. And so I'm gonna end the lecture and we'll work on the homework.
Homework.